This video is going to look at how we can find the direction angle of a vector. And to start out, I want to go through kind of explaining using the unit circle where this is coming from. If we recall, we know that if we have x in the unit circle, x is going to be equal to the cosine of theta, and y is equal to the sine of theta. So if we look at this here, if we have our unit circle, we know that our angle, if we think of this as our vector here, if this is a unit circle, well, then we know this is going to have a magnitude or a length of 1, and we have our angle theta, and then of course we're going to end up with our coordinate here, and this would be on the unit circle. This is going to be our x and y coordinate where this particular vector would land. Now keep in mind, if this is the unit circle, then we know this simply has a magnitude of 1. So our x could be represented as cosine, and our y could be represented as sine. So in other words, if we think of our vector as equaling to our x comma y, okay, so that's our component form, whatever x and y is, then if x is cosine theta, we could write this as the cosine of theta, and the sine of theta would represent the vertical. So then if we think of this as a vector v, now again, this is only going to look at the magnitude of 1 because it's a unit circle. But if we want to look at changing the magnitude, then we could say v would be equal to whatever the magnitude of v that we want multiplied by the cosine of theta and the sine of theta. So this is kind of the same principle used with the unit vector, and we want to change the magnitude. We would just take this unit vector cosine theta sine theta and multiply it by the magnitude that we want. And since we're thinking of this in terms of our trig functions, then we could also write this, well, before I do that, we could actually think of this in terms of I and j. We could write this as the magnitude of v, and we could multiply this by the cosine of theta I plus sine theta j. So we can kind of use the component form or this linear combination using I and j as our standard unit vectors. Okay, so that's just two different ways that we could write this. Now, if we think of our angle over here, if we're thinking about the angle theta, over here on the circle, then what is the relationship of our x and y if we think about the angle? Well, that's going to be related to our tangent function. The tangent of theta is equal to your y coordinate over your x. So therefore, if we're looking for the angle, we would take the inverse tangent of y over x, and that will give us the angle of the location of that particular vector. Okay, so this is just kind of a quick overview of how this is related using cosine and sine with this magnitude and the angle to determine the location of our vector. Okay, so this here, the tangent, is what we're going to use here to identify our direction angle using the inverse tangent of your y over your x. So if we look at an example, we want to find the magnitude and the direction angle. So if we have the given vector, v is equal to a negative 5i plus 4j. Now, what I would recommend is when we're looking at trying to find the magnitude and particularly the direction angle, I would always do kind of a rough sketch of where this vector is. So we know that we have a negative 5, so that's going to go negative 5, so we're going to the left, and then 4, so we're going to go up 4 units. And that's just so that we actually know that our vector is somewhere over here in the second quadrant. Okay, so now if we want to simply find the magnitude, well, the magnitude of the vector, we've done that before, so that's going to be easy. We take the square root of a negative 5 squared plus 4 squared. So therefore we would end up with 25 plus 16, which would then be the square root of 41. So here we have found the magnitude of our vector. So it has a length of 1. Well, now we want to find the direction angle. So the direction angle, that means what is the angle that we go all the way over here to locate this vector. So if we rotate around some angle theta, then we would go out a distance or a length of the square root of 41, and that would put us at this point for the vector. So we said before we're going to use the tangent function. So that means we're going to use tangent of theta is equal to your y over your x. So in this case, we know this is our x and this is our y, so your horizontal and your vertical. So that means the tangent of theta would be equal to 4 over negative 5. So if we're trying to solve for theta, that means we would have to use the inverse tangent of negative 4 over 5. And here we could go to the calculator, and for this problem we'll stick with degrees. So if we go to the calculator and enter this in, make sure that you're in degree mode, and then we're going to go to second function tangent. So we have the inverse tangent of a negative 4 divided by 5, and we hit enter, and we get a negative 38.6. Now to make this a little bit easier, I'm just going to go ahead and round this to a negative 39. So we're going to make this a negative 39 degrees. Now remember, we talked about kind of the domain and range for your inverse tangent, and we said the inverse tangent was only good from negative 90 degrees to a positive 90 degrees. And we're getting an angle here of a negative 39. Now, this is why I said earlier we want to draw our vector, because if you look, our vector is not down in the fourth quadrant, it's in the second quadrant. Well, because the inverse tangent is only going to give you an angle from negative 90 to a positive 90, we can think of this as a reference angle of negative 39, and that means that if we were to go this direction, then the angle over here in the second quadrant, this reference angle would be 39 degrees. So up here, the negative 39 that we're getting, and remember the negative 39 is indicating negative because it's going down into the fourth quadrant. But when we think of this as the reference angle, we know then this here is also going to be 39 degrees. So what we need to determine then, what's the angle theta? Well, theta is going to be equal to 180 degrees, because all the way around to here is 180, but we want to take away the 39, so we subtract away the 39 degrees. And if we take 180 minus 39, you're going to end up with 141 degrees. So this is going to be our direction angle, because theta here is going around 141 degrees, which would put us in the second quadrant. So clearly the angle is not a negative 39, and the angle should be 141. So this is one case where you have to be careful. You can't just automatically plug this into the calculator or into the formula and assume that this is going to be your answer with a negative 39 degrees. All right, let's look at another example, and maybe you want to pause the video and see if you can actually figure this one out. We're doing the same problem. We have a vector that we want to find the magnitude of and the direction angle. So we have the given vector is negative 4i minus 7j. Now here, this is in the kind of the I and J format, but if you want to think of this, we could certainly think of this as the component form of negative 4 comma negative 7, if that's easier for you, because again here we're kind of looking at this is your x and this is your y coordinate. So if we want to find the magnitude of our vector, then we're simply going to take the square root of negative 4 squared plus negative 7 squared. And if we do that, we would have 16. So 4 squared is 16 plus 7 squared is 49, and we get 65. Now, of course, if we take the square root of 65, we're going to get a decimal, so it's close to 8, but we'll leave it in the exact format as the square root of 65. So there's the magnitude, and we said this is approximately roughly a length or magnitude of 1. Now, before we go any further, I forgot to do this from the very beginning, is to actually plot where is this vector located. Well, we have a negative 4, negative 7. So negative 4, negative 7, that means we're going to have our vector pointing over here in the third quadrant. So when we go to find our angle, we know that it's got to be something that's going to be greater than 180 degrees. And once again, because we're using the tangent, we know that when we use this inverse tangent, the angle that we're going to get out is going to be somewhere in the first or fourth, because the angle we can only get out is from negative 90 to a positive 90. So if we go to the formula, tangent theta is y over x, so that's negative 7 over negative 4, and the two negatives, that would really just make it positive. So therefore, theta is equal to the inverse tangent, and I'll just go ahead and write this as a positive 7/4. The two negatives are going to make it positive. And if we go to the calculator and we take the inverse tangent of 7/4, so second tangent, 7 divided by 4, we get an angle of 60.2 or 60.3, or again, to make this a little bit easier, I'm just going to think of this as 60 degrees. I'm going to round it. So we have an angle of 60 degrees. And once again, we know that if we're in the third quadrant, it's got to be greater than 60. So once again, this is the angle that is here is 60 degrees. So that means the angle over here is also 60 degrees. So if we're looking for the angle theta, then we're going to take 180 plus the 60 degrees. And if we take 180 plus 60, you're going to end up with 240 degrees. So that would be the direction angle to go all the way around into the third quadrant. So once again, a lot of times when you take this inverse tangent, you need to make sure that the angle you get is the correct one. Otherwise, you need to use that as your reference angle to locate the appropriate angle so that's in the correct quadrant. All right, our next example we have, this will be a little bit different. We have a given vector, and here it's written as 8 times the cosine of 135 degrees, I, plus the sine of 135 degrees, J. So here again, cosine, or the I, this is representing your horizontal, your X component. The sine of 135, J, is representing the vertical, or the Y component. And the 8, now if we think of this as cosine 135 and sine of 135, we know that that's giving us, if we think of this in terms of our unit circle, that's giving us the angle. We're over here in the second quadrant, and that's the angle here of 135 degrees. And we know that this is a magnitude of the unit circle. This has a length of 1. So the 8 that we have in front is actually the magnitude. So the question here is, what is the magnitude of this vector? Well, if we wanted to find the magnitude of this particular vector, then the magnitude is simply going to be 8, because this is what's being multiplied by this unit vector of the cosine and sine of 135. And then of course this part, if we're looking for the direction angle like we did in the other problems, this is going to be pretty obvious. The direction angle is certainly what's given to us. It's the 135 degrees. So therefore That's the direction that we're going for this particular vector. Now, let's say that we wanted to write this vector in component form. If we want to find the component form of this vector, which now it's kind of in this trig form, so how can we change this to component form? Well, basically all we have to do here is use our calculator, or we could actually go to the unit circle. And if we go to the unit circle and locate 135 degrees, what's going to be the x and y coordinate at this 135 degree angle? So what we're going to do is we're actually just going to work this problem out. We're going to take 8 and we're going to multiply that by the cosine of 135. Well, if we look on the unit circle, the cosine of 135 says we're looking for the x coordinate, which is a negative square root of 2 over 2. The y coordinate is a positive square root of 2 over 2. So therefore, this would turn out to be the cosine of 135 is negative square root of 2 over 2i plus the sine of 135, that's our y coordinate, so that's a positive square root of 2 over 2, and that would be multiplied by j to represent the vertical component. And then we're simply going to multiply this. And now we know that when we multiply here, this we could actually change this negative square root of 2 over 2i and square root of 2 over 2j. That would be like stating this as negative square root of 2 over 2 positive square root of 2 over 2. If we want to write it here without the I and j, we could certainly write it as this component form. And now if we multiply by the 8, we're going to distribute the 8 to both pieces. And in doing so, the 2 on the bottom, if we take 2 into 8, that's 4. So we would end up with negative 4 square root of 2. And then again, the 8 and the 2, that's going to give you a positive 4 square root of 2. So here we have the component form of this particular vector. So once again, it's going to be the vector that we have over here, but it's going to have a magnitude of 8. So this particular vector then is going to go out so that it has a length of 8 units. All right, we have one more example of this type. And again, maybe you want to see if you can work this one out. Now this is going to be a little bit different here. We're going to be given the magnitude of our vector. So here we have the magnitude of v is equal to 3/4, and we have the given direction angle of 150 degrees. And we want to come up with the vector. So we want to find the component form of this vector that has a magnitude of 3/4 and it's going in the direction of 150 degrees. So once again, if we kind of sketch this out, we know that if we have a 150 degree angle, where is that going to be located? Well, we know that over here, this is 150 degrees. We're going to be in the second quadrant. And if we look at a 150 degree angle, what is going to be the x and y coordinate? That's going to turn out to be negative square root of 3 over 2 for the x and a positive 1/2 for the y. So here's your x and y coordinate for this 150 degree angle on the unit circle. So we're going to look at this as v is equal to the cosine of this 150 degree, and that would be your I, plus the sine of 150 degrees times j, and that's going to represent the y, or the vertical. Now keep in mind that's given us the unit vector here that's on the unit circle that goes all the way out to this point. But remember, we want to have a magnitude of 3/4. So that means we're simply going to multiply this unit vector by the magnitude of 3/4. And what that means is we're only going to look at 3/4 of this as the vector that we want. So it's not going to be even a unit long, it's only going to be 3/4. So it's not going to make it all the way to the end of the unit circle. So therefore, we would end up with 3/4 multiplied by the cosine of 150. Well, the cosine of 150 over here, we said it's going to be the negative square root of 3 over 2, and that's I, plus the sine of 150, which would be 1/2 j. And again, if you prefer to write this instead of using I and j, we could certainly use our brackets and write this as 3/4 and use the brackets here and write it as a negative square root of 3 over 2. And because we know that is the x, we don't have to use the I, it's just comma 1/2, and we know that's the y coordinate, so we don't need the j. So there's 3/4 times negative 3, or negative square root of 3 over 2, and 1/2. And sometimes you may see the answer actually left here with the magnitude out front, or we could actually distribute the 3/4, and we would end up with negative 3 square root of 3, and then 4 times 2 is 8, and then we would get 3 over 8. So either way you could write this, depends on your preference. And even if you wanted to, you could actually enter this into the calculator and you would come up with a decimal answer as well. So here what we have learned is how we can find this directional angle when we think of this using the unit circle as cosine and sine for your x and y as our unit type vector, and then using the tangent we can find the directional angle. Just make sure that when you use the inverse tangent that we have the correct angle, because the inverse tangent is not going to always give you the exact angle that you need depending on which quadrant the vector is located.